at the API Days global event here in London. My name is Shreshta Shyamsundar. I'm a distinguished technologist with Infosys, and I have 22 years of experience designing and building enterprise systems, with the last 12 building and scaling APIs at scale. I've published more than 50 papers and articles in the field of machine learning, artificial intelligence, cloud and digital engineering, and therefore have developed a deep familiarity with this topic. Now, to address the elephant in the room, are APIs getting obsolete? What is driving the growth of these protocols? And is it the end of how APIs as we see them? History is one of those subjects that typically those who pursue science as a career tend to ignore. And as history repeats itself, it's important to understand what is our threat or attack surface in order for us to expand and respond in the appropriate fashion. Let's take a look at how APIs have evolved in the last 20 years. If you look at the pioneer age, Amazon developed its first API in 2002. It helped turn book into data, into accessible assets. Jeff Bezos even made a mandate that everything must be an API. Between 2010 and 2020, that moved forward and REST became king. JSON was the universal language. The rise of several API first companies marked this particular period. The payment platform Stripe processed $18.4 billion worth of sales in just 5 days as part of a Black Friday event. In that decade, 85% of the enterprises adopted microservices and microservices architecture. In this particular time frame, the mature age after 2020 kicked in, delivering what we understand today as the API economy. In this particular period, you could see that 57% of all internet traffic came as API requests. A market size ballooned in excess of $200 billion. And this is projected to grow to 420 by the end of the decade. What's important to note is beyond some of these numbers, such as 62% of the developers' APIs that they created actually were monetized. A lot of this particular activity results in what we see today as traffic across what Cloudflare reports in this world in terms of all sorts of money being exchanged. Your morning coffee that you probably ordered today has traveled over 47 different APIs before it reaches your cup. Payment processing through to supply chain, through to loyalty programs. API landscape tells a very good story, but they are not without challenges. Despite it having a lot of trends that are defined across various industry segments, for example, healthcare has defined something called FHIR. Finance has open banking. Telcos have the PM Forum's open digital infrastructure. These are trends that go beyond API monetization or faster development and faster deployment. But with great power comes great complexity. API sprawl, security vulnerabilities, integration overhead have reached breaking points. 39% of the adopters have also cited that they have difficulties in understanding and appreciating documentation, discovery, as well as the asynchronous workflows are also becoming very difficult when using APIs. This essentially has heralded the incoming of a new era as the storm clouds have gathered in terms of those challenges coming to front. The agentic disruption is here. There are concepts of agentic AI that do not think in what we see as HTTP verbs. They think in terms of goals and context. Traditional request response parameters clash often with continuous conversational AI needs. The rise of the AI first architecture is questioning what we have traditionally seen as API centric design. Just as mobile apps didn't kill websites but transformed them. We are at the vanguard of change to see that agentic AI isn't killing APIs, but it's demanding that they evolve to the next segment. Now, what is the agentic revolution? It's got four aspects for us to consider that the APIs do not necessarily respond to as capabilities. First, agents are context aware. They recommend and remember based on previous interactions across time and systems. They are goal oriented. They work backwards from objectives and not forward from endpoints. They operate in a peer to peer fashion, agents collaborating directly without human orchestration. They are also real time adaptive. They are able to adjust their behavior based on live environmental changes. So, this demands an entry of new protocols. Let's first discuss one of them called MCP, Model Context Protocol. Think of it as an individual empowerment. This construct was developed by Anthropic and released to us last year. The purpose of this was to enable and building secure two-way connections between data sources and AI-powered tools. The idea here was to enable persistent context to be made available to these models and tools at scale. From an architectural standpoint, it used the traditional client server model, but then leveraged JSON RPC as a construct across transport protocol. From an innovative standpoint, it maintained stateful connections and necessarily allowed for hallucinations to be reduced at scale through direct tool access. It empowered the usage of a phrase as MCP to be equivalent to the USB Type C port for all AI applications. If you look at its growing ecosystem, several concepts like Google Cloud, GitHub, Slack, Postgre all support this standardized interface. Central to this protocol is its ability to focus on enterprise security requirements as well as enable community driven development with all their specifications open to the public and SDKs available for adoption. Imagine an AI that remembers your last conversation that may have happened several weeks ago, but is able to seamlessly access your calendar, email, and project tools without losing any context. That, my friends, is MCP, essentially empowering individual agents to do better, giving them arms and legs in order to function more appropriately by adding value. But what about when agents have to collaborate with one another? In such cases, we have the collaboration framework in the form of the agent communication protocol. This was the construct that came out of IBM and BAI and launched earlier this year. This is a REST-based standard, thereby enabling seamless agent-to-agent communication. The killer feature is that it allows agents that are built using different frameworks, different languages, and environments to seamlessly communicate in a lightweight and HTTP native setup. It focuses on reducing several integration errors previously reported across multi-agent communication paradigms to the point that its framework agnostic interoperability has given rise to multiple agents working together to solve a greater goal. If I were to take one example, think of a case where there is a multi-agent research team, which involves an AI researcher, a scheduling assistant, and a mathematics agent, an agent that is proficient in the subject of mathematics. But now these agents can instantly converse and coordinate tasks. The ACP protocol enables the researcher to request for data analysis to be carried out, the assistant to schedule collaboration sessions, and the mathematician agent to perform complex calculations. All of these direct agent to agent messaging has every exchange logged, tracked, and contextually threaded to make sure that all of these conversations where the agents can broadcast updates, delegate tasks, and also share findings in real time is available to the user so as to enable a fluid goal driven project without any manual orchestration. The ability to contain structured data across plain text, images, or even video, enabling multimodal message support, expands the possibility of how these agents can collaborate and while remaining asynchronous by default. The SDK optional feature allows it to be used directly through HTTP clients and can even access agent information while being offline. These capabilities allow for inter-organizational collaboration and cross-company workflows which were unseen until this particular point. Taking a quick look back, if you look at MCP, it individually empowers the agent. ACP necessarily enables agents to work together in a collaborative manner. What if we take this a notch up and think what would it look like if it were up on an enterprise scale? Enter agent to agent protocol developed by Google. This was developed and launched earlier this year with support from over 50 different technology partners. The idea was to have an open protocol for secure, cross vendor, and multi agent collaboration at enterprise scale. The idea was to build on the existing established standards, but have a specific purpose on security and remain agnostic, similar to ACP, across the multimodal setup. It should support text, video, audio, and other data formats. The idea here was to enable enterprise grade security and reduce latency in terms of allowing agents to collaborate and cross functionally exchange information in a way to make sure that at an enterprise level there is value being added. If I were to take an example similar to the previous case, envisage a scenario that across an enterprise, there's an AI workflow orchestrator. Now, this AI workflow orchestrator delegates, say, there is a report generation capability. And this report generation capability allows for the report generation agent to work with the analytics agent, and they pass findings across from one agent to another agent to ensure that the customer engagement agent uses this information to trigger a personalized outreach program. All of this using this particular protocol. Some of these activities may take several days, maybe several seconds, or several weeks. The A2A protocol supports long running tasks. It also allows for agents to discover other agents through a standardized capability and allows these agents to plan and leverage complementary skills in order to deliver the appropriate outcome. This enables dynamic automated business processes unseen before. It allows for these processes to update and respond as new agents join and leave the workflow, which was also a new feature not seen in protocols prior. The important story across these protocols is one, focuses on empowering agents, two, allows them to collaborate, and three, sets up a framework for the enterprises to necessarily work together in order to deliver a greater goal. Now, let's look at how they necessarily compare against one another. In terms of this comparison, it's important for us to look at what tool do we use when. In this particular segment, the purposes vary, but the specialization essentially allows for agents to necessarily work together, collaborate, access the required tools in order to deliver the outcome. If I were to put it in one sentence, MCP is perfect for individual AI assistants. that need specific tool access to deliver specific outcomes. ACP is more for creative, flexible, multi-agent scenarios, and A2A is for enterprise scale, secure agent workflows. With all this as a protocols that is available, what happens to our traditional API models? What are the aspects that we need to necessarily see as an evolution in order to make sure that we continually relevant from an API design standpoint? So what I present to you are 6 different facets for you to consider as part of the evolution paradigm. First, a communication pattern. Traditional APIs work in a request response client server model, but do not support a multi-directional approach that the agent protocols do. From an interaction model and a schema standpoint, they are primarily synchronous and observe a rigid structure. Agent protocols are generally dynamic and asynchronous. From a context awareness standpoint, agent protocols have a rich, wider context as compared to traditional APIs. And initiation and collaboration also see a lot more human and system level triggers as opposed to more autonomous when it comes to agent protocols. So if you were to put all of this into a nutshell, traditional APIs excel at more established enterprise systems, more at the source of truth level, where there are well-defined business transactions. Agent protocols are more so for cross-system orchestration, where there is exploratory work that is required. If you have to take it up a notch to see what the future could look like, think of the future as a hybrid arrangement. When I say hybrid arrangement, what I necessarily mean is think of it as a layered cake. The first being the foundation, where the traditional APIs handle core system interactions, integrations, data persistence, and legacy systems connectivity. Layer 2 is the intelligence layer, which allows for the agent protocols to necessarily manage AI to AI communications, context sharing, and autonomous task coordination. Moving it up further, within layer 3 is more the experience layer. We see this part also moving away from standard into hybrid interfaces and maybe even AGUI. The important part in terms of complementary strengths is that APIs are used for reliable, standardized, optimized, machine to machine efficient protocols. And agent protocols are used only in the case of context aware, goal oriented scenarios. So when they are brought together, you can see the ecosystem where traditional systems feed context to AI agents, and the rest can orchestrate complex workflows. Taking an example from the real world, consider a modern banking example where the open banking APIs handle transactions, MCP provides context to AI advisors, and A2A enable fraud detection agents to collaborate with these compliance systems, all secured through traditional API gateways. This is how we see a real world implementation where APIs continue to be relevant, but more so in a cross functional manner. Now, let's see what that means from a developer standpoint. How do we see this sort of a hybrid architecture model influence what a developer can add, or how what it necessarily means from a developer standpoint? We see that developers are going to have an evolving role. There'll be newer skills that will be called upon in terms of being able to understand and process agent behavior patterns, context management, and conversational flows, and a deepening appreciation of security, both from an endpoint protection standpoint as well as the ability to trust networks and behavioral monitoring. There would also be an evolution from a governance standpoint, managing not just data flows, but agent autonomy as well. So the developers will need to develop a specific toolkit. While it's still essential to have a deep understanding of traditional APIs, understanding agent protocols, hybrid monitoring, and context architecture is going to be crucial in order to stay relevant from a skills management standpoint. And if I were to take it up further of how I see the security and governance evolve, there will be a lot more focus on zero trust agent networks and the ability to implement a dynamic policy enforcement to make sure that the agent behavioral patterns stay within the guardrails. The protocol adoption roadmap, as we see, we are currently in the stage of early adoption, but the next few years will guide us into maturity and make sure that the protocol standardization and interoperability becomes an even more widely adopted standard. And necessarily, compliance will be driven by design. In terms of the call outs that I'd like to see us take away, APIs are evolving, not dying. The future is a hybrid architecture that combines both traditional APIs with agent protocols. Agent protocols, such as the ones we discussed today, each solve a specific challenge to make sure the AI agent communication and context managements are preserved. What's important for us to think about going forward is that we experiment with these protocols, understand their roles, and accommodate them to make sure that our complex workflows in conjunction with APIs become a reality. We need to prepare our existing APIs for a hybrid future, and let's build that future together. Thank you very much. I hope you enjoyed the rest of the event as much as it took us to build this presentation and bring our research to you. Thank you very much.